on details on the ball of Saturn, on the planet Saturn itself. There is not much in the way of spots, which is a bit disappointing because we had hoped to get precise rotation rates and thereby a better information on jets and streams in the atmosphere of Saturn. The structure, however, of belts and zones is beginning to be seen and looks somewhat different from that of Jupiter, whereas from the Earth already we knew that there are in an hemisphere, say the northern hemisphere, which is the one that we're observing best right now, on the order of 5 belts and 5 zones. So that was known from ground-based observations. It now looks that there are many more of these bright zones and dark belts, perhaps twice as many.
This is Pioneer Saturn mission operations. The spacecraft has now moved to within 700,000 miles of the planet Saturn, and it's moving closer at just about 26,000 miles per hour. As we learned in the press briefing, we now believe we know what our problem with the data has been. There was a major solar event some weeks ago. Particles from the sun have made their way out into interplanetary space and have now enveloped our spacecraft and the planet Saturn. The most apparent result of this will be smaller pictures on our screens, and we will not be able to show as much area of the planet in each image as had been expected.
Since I'm a radio man, I'm kind of fascinated with the radio system of the Pioneer and the DSN, and I'm very impressed by the fact that all of these data are received from a distance of just about exactly 1 billion miles. At this distance, if you are transmitting 1,024 bits per second, at any given time there are 5.5 million of those bits strung between here and Saturn, traveling at the speed of light, 5.5 million. And they're spaced 182 miles apart. And with that, I'll quit.